Now, students, I'm going to teach you. Student, today, now I'll start accelerated fluid, right? So, student, either you can say accelerated fluid or you can say concept of acceleration in fluid static, right? So here we are. We'll go through this. So here, student, will today I'll start this topic as I say. So, what is things, student, which we have keep in our mind? Student, I'll give a little brief. Students, I'll give you little brief of I can say statics. What, my dear student? You know, fluids are at rest. There are two conditions. Fluids are at rest, and next, what you can say, beta? Fluid is in motion. So, student, you can just understand. As I can say, beta, recap, right? Students, you can now, students, I'm considering, my dear. This is fluids. Fluids are at rest, right, my dear? If are fluids are at rest, then beta, what is a change in pressure difference? Students, change in pressure difference. This is plus minus what beta is rho gh. This is a bit of formula. If fluid are at rest, then delta P is what? Plus minus rho gh. So, no, there are two cases, right, my dear? Student, this is case one. What, my dear? This is case one. So, what is case one? If your motion, students, if you are just coming in downward directions, if your motion, what is doing in downward directions, right, my dear? So, pressure is what? Pressure is increases with depth, my dear. Pressure is increases with depth beta, right? So this condition, what you will write, students, delta P. So we can write, my dear, delta P is what? Plus rho gh. What is your direction of motion beta? This is, you can say, if you are moving, if we are moving in downward direction. What is students? If your motion in what, my dear? In downward direction. Right, beta? Okay. Student, this is case 2. Students, I'm calling dear. What is case 2? Pressure, student, decreases. Beta, this symbol is what? This arrow is what? In downward direction, beta. So what you can say? Pressure decreases. Pressure decreases with what, my dear? With height. With height, right? Student, already I uploaded remaining lecture like how plus rho GS minus rho GS, how came rho GS. So you can go and watch remaining lecture 1, 2, 3, 4 like that. Right, Vita? Already uploaded, I can see on the same channel. So pressure decreases with a student's depth. So here you can write change in pressure is equals to minus times rho GH. Minus time what beta? Rho gh. If you are moving in what beta? If you are, my dear, moving in what beta z? In upward direction. Your motion in upward direction, fluid is at rest. So what's the change in pressure? Minus rho gh. The student, pressure increases with depth. You are coming in downward direction. This is plus rho gh. Now, students, I want you to discuss because this is the condition for fluid at rest. So next student, I wanted to discuss that is, you can take for next consideration. So what is student? If a fluid are accelerated, what, my dear? If fluids are accelerated, this is what Vitaji? If fluids are accelerated, right? Then student, there are again, there are two cases, my dear. There are two cases, my dear. So this is case one, I'll take, my dear, first. This is case one, right? you can say motion of container in what vertical upward direction. So vertically upward motion of container beta. This is case one, my dear. Vertically, this is what beta G? Vertically upward motion of container. What, my dear? Vertical upward motion of container beta. Okay, fine. So, students, here, what I'll take consideration. I'll go slowly. Just listen to me carefully, beta. You can connect easily. You can connect easily, beta. Now, students, let us suppose I'm considering a container which is filled with water. Students, here I'm considering a container which is filled with water. You can see water filled till neck of the container. What, my dear? Water filled, student, till neck of the container. Right, beta? Okay. And container motion, what I'm considering? In upward direction. Container motion in what, beta? In upward direction with acceleration A. This is the condition, my dear. Basic things. Right. So here we have to find what is the pressure difference. What is the pressure difference, my dear? Okay. So students, here, beta G, just we'll go through this. Let us suppose, students, now I'm considering here one imaginary cylinder of water. What, my dear? Here I'm considering, student, there is one imaginary cylinder of water, right? Okay, so student, this imaginary cylinder, I'll keep it out. What, my dear? I'll keep it out, right? Okay, so here, students, this is the cylinder. Right. So I can say this is FBD. Now, students, I'm drawing FBD of cylinder. This is what imaginary cylinder made up of water. Right, beta. Okay. So now, students, let us suppose I'm calling this is point P. This point, student, I'm calling R. This point, students, I'm calling R. Right. Okay. So students, here I can say, Bachcha ji, this is, because container open to atmosphere, beta. Container open to atmosphere. So students, here you can take for consideration pressures due to what? You can say pressure due to what, beta? Atmospheric, which is acting on what? Top of the container. So students, here you can write force basically we are looking, right? So you can say P naught, what beta is it? P naught, or you can say P naught here only with us. Here we can say this is P. You can say pressure at point P into what, beta? This is what you can say area, right? This is A. Area is of area, beta. You can take for this cylinder cross section. Now, students, there is some mass of the cylinder, beta. So you can write over here. This is what basically mg. This is what, beta? Cylinder of mass. What you can see, this is what? Mg. Students, here I'm considering this is what? H is the what? Height of the cylinder. H is the what, beta? The height of the cylinder. Okay. Now, students, already I represented downward forces. One, this is, you can see pressure at point P and area. This is the force. Mg also force. Student, no. Student, you can easily tell, sir, this is the point. Also, this point also contact with water. So there is one more force you can represent over here, dear. So this is pressure at R into A. Pressure at R into A, my dear. Okay. Now, students, just simply you can equate. Simply you can equate beta. Right. So we'll just have a look next. Hmm. Yes, beta. So this is also again a BD of cylinder. So now, students, basically imaginary, which I have taken cylinder, which is made of water. So there is a pressure at point P into A. One pressure here in this direction, student, pressure R into A, and one is mass. That's all. Finished. Students, S is the what? Height of the cylinder. H is what, my dear? Height of the cylinder. So now this is ABD finally. So simply student now onwards, you can apply FNet, NLM. I hope all of you remember NLM concept. So students, summation of beta, this is FNet is equals to what, my dear? MA, simple. Fnet is equals to what, my dear? MA. Okay, now we can say entire motion, container motion in upward directions. We can say imaginary cylinder also motion in upward directions only. Right, beta? Okay, Fnet is what you can say. Fnet means who is the driving force? You can see system motion in beta upward direction, right? So this is the force. Tracer R. R is what? This point I have taken. So this point I have taken, my dear, R. This point beta I have taken P. So this is what? You can see motion in upward direction. So you can say, my dear, this is the larger force. This is what? Lesser force. Right, my dear? Okay. So here you can write, my dear, pressure at R into A minus beta, pressure at point P into A. This is what? M into A. Students, mass I wanted to write in terms of beta density. So we can say density is equals to what, my dear? Mass per unit volume, right? So we can write, my dear, mass is equals to density into volume. That's all. Okay, so density beta, I know there is, you can take some density. So usually beta, this is made up of water. So you can take as usual rho beta. There is no change at all. So mass student, this is rho. Rho is what? And what is the volume? Volume is what? You can say area into length, my dear. Volume is what beta? You can say area into length. Volume is beta, you can say area into length. Okay. What beta ji? Beta ji, if area into length here, then area is A, and what's the length beta ji? This is H. You can take, my dear. This is rho AH. So now student, this value can feed over here. So pressure at R into A minus beta Z, pressure at point P into A is equals to beta rho AH into A. Rho AH into A beta Z. Okay, you can say everywhere. Sir, this beta Z area cancel everywhere. Beta, what we can see? Area cancel everywhere. Okay. Now, beta, one more force missing over here, yeah, because mg force also acting over here. So you can say, beta G, this is the, just I'll rewrite again, my dear. Pressure at R into A minus pressure at point P into A minus mg beta. This is missing out. Is equals to n beta G. So already I said everything, so I'll use with a direct result. PR minus pressure at P into A is equals to M into what beta G? G plus A. Right, my dear? So simply beta, I'll just use mass value from here only directly. So students, PR into A minus pressure P into A. What students? Rho AH into beta G, G plus A. You can see this A cancel with here. So what is the pressure difference which you can write if container motion in upward directions? PR into A, my dear, pressure at P into A is equals to rho H. This is what, my dear? You can say A plus G or G plus A. Student, you can replace this entire things to what? This is known as Z effective, my dear. This is known as, my dear, what? Z effective. So finally, students, you can write PR into A minus PP into A is equals to rho. This is what, my dear? J effective into H. So this is which you can keep in mind as a result if container motion in what? Upward directions. So student, as I said, fluid is at rest. There are two pressure, delta P plus rho GH if you are coming in downward directions, delta P minus rho GH if you are going in upward directions. If fluid is in motion, there are two accelerations which you can define. what is I have taken this one. This is case number one. Means if fluid is in motion, then you can define acceleration in both directions, horizontal also, vertical also. Right, my dear? Okay. So here, beta, what you can say, what I have taken container motion in what upward direction, right? Result beta G, we can say this is PR into A minus beta PR into this is what motion in upward direction. Now, student, I can say next. This is what, my dear, case 2. This is what, my dear, I can say this is case 2. You can say container motion in what? Vertically downward beta G. This is vertically downward direction. Motion of container, what student, in vertically downward direction. Okay, beta. Okay, now students, again I'll take as usual this is the container, my dear, right? And this container is what, beta? This container is what? Till neck, students, you can take this is filled with water. This is what, my dear, filled with water, right? Okay, fine, beta. Now, students, what's the condition for this thing? Container is coming in downward directions with acceleration A. Again, we wish to find pressure difference. Again, we wish to find pressure difference, right, beta? Okay, I can see, bacha ji, for this condition, how can we find pressure difference? Beta ji, again, students, here I'm considering, student, here again, students, I'm considering what, my dear? Tell, this is what? Imaginary cylinder of water, right, beta? So here I'll make this is FVD of imaginary, what, beta G? FVD of imaginary cylinder of water, my dear. Okay, so student, I'll take this is out. Students, so this is the things here. I'll make diagram little big so that you can enjoy the class at physics point. Student, any queries you can write in chat box, right, my dear? Okay, students, again I'm considering beta. This is H. H is what? I can say beta G. I can see beta what? This is the length of the cylinder. Now beta, again students, I'm considering this is the point P, this is the point R. Student, this is again here we want to write expression of force so that I can equate F net is equals to ma, my dear, right? So beta, this is pressure at point P into A. It's a force, my dear. mg, students, acting in downward direction. So this is this part is also contact with liquid. So students, here you can write this is what, my dear? Pressure at R into A. Simple, beta. Student, already I represented all the forces. Students, here now I'm going to apply summation of what, beta? NLM, concept of NLM, students. Summation of F net is equals to, my dear, MA. Right, beta? F net, simple. No, this is very common things. Maybe all of you finished like work power energy, NLM, friction, rotation, center of mass. So I'm expecting all of you pretty confident to write this formula. Anyone from all of you, can you write in chat box? Anyone from all of you, can you write in chat box? How can you write F net? mg plus pp into A minus this force equals to ma. Am I right? Anyone? Can you write in chat box, beta? Anyone from all of you, can you write in chat box? Anyone from all of you can write in chat box? Anyone? Okay. So students, now what I can say, beta, I'm writing beta. This is in downward direction, beta. So here, this is no driving force always more, beta.
you can write this is mg minus, my dear, this is plus plus, both are in same direction. You can add the forces beta only. Pressure at point P into A minus beta g in upward direction, sir. Pressure at R into A is equals to, my dear, MA only. This is why what, my dear, MA only, right? Okay, now students, you can say beta g for this condition. This is what beta g, MA only, na? So mg beta, again you can use same principle beta, right? Mass beta, again you can write this is rho A into H, right beta? Okay, already I don't want to waste time, bacha. Already I said how this is. I can say the same thing, beta. I explained a bit previously as well, my dear. So this is beta. Just go through this here. So what you can say, pressure at P into A minus beta, pressure at R into A is equals to beta g MA minus mg. MA minus mg beta. Now students, I can write pressure at P into A minus beta, pressure at R into A into what, bacha ji? You can say M, you can take common beta. This is A minus G. What beta ji? You can take beta G, A is common. Right beta? Now bacha, you can say beta G. This is the condition. Mass beta, just replace this one. Mass beta, replace this one, right? The pressure at P into A minus, student, pressure at R into A. Mass, student, what you can write? You can write, student, rho AH into beta, this is A minus G. Into beta what? A minus G. Right beta G. Okay. Students, what I'll write? You can say, sir, this area cancel. There is no doubt at all. Now students, you can say pressure at P minus beta G, pressure at R is equals to what beta G? Rho H. This is A minus G. Student, here I'll take common minus, right? Minus common beta G. Students, here I'll take minus is what? Common. Now beta G, I can say minus is common beta G. Right? If I'll take minus common beta, then I can write pressure at R. What beta G? Pressure at R minus beta, pressure at P is equals to rho H into G minus A. Student, I can see all of you, beta G, dedicated here. I can see till night 12 o'clock you are in the live system, beta. So this is beta. You can easily understand, my dear student. You can easily understand how, student, you can easily understand, because you can easily also remember, beta. I hope all of you remember, right? Elevator case, students. I hope all of you remember what, beta? Elevator case, right? In elevator case, beta, no, this is a repeat. Just I'm telling you connection. You can easily connect, my dear. God bless you everyone here. Till now 12 o'clock you are on live session. Really bacha, it's your dedication. It's your dedication, my dear. I'm very happy to see each and everyone, beta. Right? Any doubt, anything, beta, just write in, beta, I can say chat box, beta. So this is, student, everyone. If I can say, beta, in the lift, if you are going in upper direction, so what is the normal, beta? G plus A. This is same thing, bacha. Container motion in upward directions, beta. What is the pressure difference? Rho of G plus A, beta. Now here, beta, what I can see, this is G minus A. So simply you can remember pressure difference for container, either motion in upward directions and downward. You can replace to what I can say concept of elevator, my dear. Right? Students, after this, beta, I can say I'm going to start, beta, the next thing. Student, you can take snapshot. Student, you can take snapshot, beta, for your betterment. Now, bachas, have a look next year. What's the next concept? Beta ji, after this, as I said, beta, pressure variation, you can write. Pressure variation, beta, you can write in both directions, horizontal as well as vertical. If fluid is in what, beta ji? Motion. Students, if fluid is in what, you can write in motion, right, beta? So, beta, what is the next heading here? What is the next heading, beta? Okay, beta ji, here you can say, beta, horizontal. Now this is you can take beta g. Let us suppose, student, this is B is to write pressure you can say beta difference, pressure difference in what? Accelerated fluid, accelerated fluid in what beta? This is horizontal, this is what my dear? Horizontal direction, right bacha ji? Pressure difference in accelerated fluid in what my dear? Horizontal direction, right? So students here I can say bacha ji, you can take it a consideration, but it's a closed container. Somewhere student you can also get it. This is what? Closed container, right? So this is a container, a student, which is filled with water. Now motion is what beta? Towards right. You can take beta, this is the container, right? Okay, and what's the, you are dragging container in horizontal directions. So here student, again you can take as a consideration my dear, imaginary cylinder of water. What my dear? Imaginary cylinder of water, right? So I'll take it out so I can easily make FBT beta. So this is imaginary cylinder my dear, I'm taking it out, I'm taking it out. So students, I can say this is what beta is the imaginary cylinder. This is, you can write, because entire container motion towards right, to this cylinder also motion towards right only. Students, you can take beta, this is point A, this is point B. Student, here I want to write pressure difference formula. So what I know this because you know this is the surface of a container, this is surface of imaginary a cylinder of water, contact with liquid. So this is the surfaces can feel a force towards right my dear. So you can say there is what beta? Pressure at point A into what? Area bacha. Now students, you can see in this direction. What my dear? Pressure at point B into area. Pressure at point B into area. Right my dear? Here students, again you can apply same thing. Concept of what beta is the annulum. From what beta is it said? Equation of, I can say beta, how to write equation of motion. So this is student, again I am using your concept of annulum student. F net is equals to ma. Now system motion in this direction beta. So you can say this is the larger force. So pressure at A into area minus beta g pressure at V into area, which is equals to beta g ma, which is equals to ma beta. Students, here I am considering this is what? L is the what my dear? L is the length of imaginary cylinder. L is what my dear? Length of imaginary cylinder, right? So this mass students I can write, this mass student I can write, this is what my dear? Rho, tell beta everyone, rho A L. I hope all of you remember beta. All of you understand. So this is students pressure at A into A minus beta g pressure at V into A. M is what beta? You can say rho A L into A. Students, you can see this A finished. So PA minus PB is what my dear? Rho LA. Now onwards keep in your mind, if you have a closed container, if you have a closed container and container motion towards the right, so what is the pressure difference? So student, now onwards keep in your mind, highly important, which I'm teaching you to know. First student, I'll cover entire theory of accelerated fluid, then I'll give a number of possible numerical. So stay in lights, my dear. So PA minus PB is what? Rho LA. Just keep in your mind, my dear. Okay, have a look next, beta ji. After this, students, what is the next concept? Student, pressure distribution in an accelerated frame. What student? Pressure, this is what student? Pressure distribution, pressure distribution in an, what my dear? In an accelerated fluid. This is in an accelerated fluid. Okay, so here students I can say the things, right? How bacha ji, literally it's a very helpful beta and superb important, highly weightage, I can say fluid static. So know what is the condition here. I'll make more ABD so that you can understand the things. So let us suppose I'm considering here, this is case 1, which is I can say weakening of the fluid static. Since this is the container which is filled with a liquid, this is a container my dear which is filled with a liquid, right? Student, there is no acceleration at all. Student, there is no acceleration at all. Okay, now student, this is, you can take for consideration case A, same diagram student. Now I'm going to students, this is, I'm going to you can say like provide, and I wanted to, I can say, drag this container in horizontal directions with acceleration A, beta. This is the condition. You can see this is options B or case B beta, right? Okay. In case 3 beta, what is I'll write if you are just dragging the container in horizontal direction. If you are dragging the container in what beta G? Horizontal directions. No, then how can you can you can say like imagine a layer of fluids, right? So student, this is finally beta, you can just make diagram of the like say fluid surfaces, right? So students, for this condition you can tell, sir, this is the basically this is the, you can say finally you can feel beta. This is which you can say, you can observe beta G, this is layer of fluids scenario, right my dear? Okay, so student, here there are many questions, they can frame, right my dear? So I'll go one by one, I'll go student one by one. First student, I wanted to find, find angle of inclination. What we need, just I'll write questions here. Find angle of inclination. Please solve JEE means question. Student, I can say beta, JEE means question you wanted like which question already came beta, those question, or just you wanted questions based on this beta? Shubham, newly joined beta, just a bit here. First I'll finish a student entire theory, then student I'll give you entire students like questions based on this beta. Question means advanced, I'll say already I see beta, I'll do questions only. First I'll finish theory beta G. Find angle of, these are questions beta already asked in JEE means here. Find angle of inclination, find angle of student, find angle of inclination. Shubham, can you answer me this question, my dear? Shubham beta, can you answer me this question beta? Find angle of inclination, of beta G, this is free surface of beta G, free surface of liquid, beta G from horizontal, right? No beta, this is the free surfaces. So you can tell beta, this is the angle which we wish to find, Shubham, beta, this angle I can find by two method. One method beta literally easy. Second method there is a little application of beta, I can say like analog, right? So first I'll teach beta, this is method 1. This is what my dear, method 1. Okay. So what is method 1 beta ji? Simply you can say this is the layer of fluids. So definitely there is some mass. right beta. So I'll make here this ability over here, which this is ability beta. You can say this angle is what, my dear? This is basically theta. M is what? Mass. So you can write, a student, this is what? Basically mg. This is what basically mg. Container motion, student, no, this is in this direction. So due to this, student, you can take in consideration this is what pseudo force. I hope all of you know pseudo force always acting opposite to directions of motion of container, my dear. So this is, you can say beta g ma. This is what you can say ma. Simply, student, you can find theta from here, because this is a theta, this is 90, this is 90 minus theta beta. So you can see this angle is remains theta, my dear. This angle is what remains theta, my dear, right? So simply beta, all of you know, you can just make one more diagram for your clarification beta. Physics is student language of ability, and here at physics point I'm always trying to give my best, and each and every student can feel comfortable, right beta? So this is the condition beta. So this is theta. I hope all of you getting my point. So this is what beta, you can see this is what basically mg, and this is what, my dear, you can say ma. So simple, student, you can apply tan theta formula beta. You can write, my dear, tan theta. What is tan theta beta? I hope all of you remember perpendicular upon base. Perpendicular upon base. So what's perpendicular base party? This is ma, you can write beta. So you can write, a student, for tan theta. Student, for tan theta. Perpendicular is what? Ma bacha ji. Ma upon what, my dear? Mg. You can say beta, this is cancel. So finally, students, you can write as a tan theta. As a tan theta, what, my dear? Tan theta is what? A by g, or you can write, my dear, theta is equals to tan inverse A by g. So we wish to find theta basically. Theta is what? Find angle of inclination. This is the free surface of a liquid from horizontal, which I have done, right, my dear? Okay, now students, I can say same result I can find from concept of NLM. From concept of NLM. Okay, so now this is, students, I can say method 2. Let us see. This is what can I say? Method 2. This is the same question, student. I'll do by method number 2 as well, right, my dear? Okay, so this is what is method 2, students. Here I'm using student concept of students NLM. Students, here I'm using what? Concept of beta g, I can say NLM, right, my dear? Okay, so student, no, this is everyone, you can say, sir, this is the free surface. This is what, my dear? This is what basically theta. Sir, mg force acting in downward direction. Sir, pseudo force acting in what? This direction. Student, just take component of mg beta. You can say, sir, this is theta, this is 90, this is 90 minus theta beta, this is what remains theta. Student, mg belongs to quantity vector here, so you can take component beta g. This is mg cos theta. Now we can say, dear, this is mg sin theta. By the way, one time you can think, student, sir, mg cos theta is balanced due to normal. You can think like that. But how can I balance mg sin theta? Because everyone know this is what you can say equilibrium condition. What is the meaning of equilibrium condition? Net force balance. Net force balance. But this is what, my dear? This is not balance. So you need to call what? Pseudo force. You need to call what, my dear? Pseudo force. Pseudo force always acting opposite to motion of the actual motion of the body. Everyone know. So this is what? Motion of body in horizontal direction, my dear. So we can see pseudo force acting in beta backward directions of motion of the actual motion of the body. This is beta theta. You can tell, my dear, this is 90 minus theta. You can tell student, sir, this is what remains theta. Student, just it can be a take component of MA. This is what MA cos theta. What bacha ji? MA sin theta. So you can write, my dear, this is what, my dear, everyone. You can write, student, sir, this is MA cos theta. This is what, my dear, MA cos theta. This is what, my dear, MA cos theta. Now, student, you can say, sir, this is what? Balance each other. This is what, my dear, balance each other. Along the beta, what? You can see incline. Along the incline beta, you can see this is balance each other. So now, students, you can just write beta G MA cos theta is equals to what, my dear? Mg sin theta. Cancel. A, students, you can write G tan theta. A beta G, you can write this is what? G tan theta. Right here. Okay, so same result I proved by two methods. One is, this is method from NLM, and one is, I can say, normal geometry. Now, student, what is second question? There are questions, student. So first question already I solved. So this is question number 1. If your what, you can say, if your container motion in what beta G, you can say towards right directions, right? Students, now have a look next questions here. What is question number 2 beta? Question number 2, students, you have to find beta, this is net acceleration. You have to find beta G, this is net acceleration. Okay, so how can you find? Easily you can do beta. All of you, literally, I'm very happy to see all of you beta. Stay just in the live session beta. You welcome at Physics Point, everyone. Now beta G, all of you can say, sir, this is what? MA. This is what? MA. This is what, my dear? You can tell everyone, sir, this is MG. Student, all of you know, we wish to find acceleration here. So student, you can just ignore mass, right? You can also make beta one more diagram. Sir, this is, we wish to find acceleration. Sir, why you are writing mg? You can write only g, sir. This is beta g a. Students, you can see everyone from geometry or this FBD, sir, both belongs quantity vector. If both belongs quantity vector beta, then what you can say? Simple. So we wish to find net acceleration. So sir, we can apply this formula na, acceleration net, because acceleration belongs to quantity vector. If you wish to find summation of two vectors, so definitely you have to apply the formula. That is what, my dear? A square plus beta g, b square plus 2ab cos. What's the angle, student? This is 90 degree, my dear. This is what? 90 degree. You can see this is remains 0 beta. So you can write acceleration net is what, my dear? This is basically a square plus g square. So they can ask, just I can say till now I finished only 2 questions. What is the theta from, I can say, horizontal of a free surface of a liquid, and what is the net acceleration for these situations? Right here, you know, student, they can ask more questions. Now from equilibrium of liquid, we can state that the pressure of every point in a liquid. So listen, this is the I can say beta highly important point. What bacha? Let's have a look here, students. Now students, from equilibrium of liquid. This is students. Now from equilibrium of liquid. Now from equilibrium of liquid, we can state that pressure at every point of a liquid layer parallel to each other. What here? Liquid layer parallel to each other, right? From free surface, which is not horizontal. You know, these are parallel surface. You can see here, all are parallel, right? And horizontal, all are parallel, but here all are parallel but not horizontal. If they are not a horizontal student, then you can write more expression, more things you can think about this situation. So what, my dear, let us suppose I'm calling you like this, these all are concept beta. So you need to write beta for this condition. You need to write what is the pressure at a particular point. Let us suppose students, it's a concept, I can say for accelerated fluid in horizontal direction. Student, you can think like that. This is the container. This is container, my dear. Now you can say this is students. I don't want to turn the page with more time. That's why I'm making diagram over here. Now, student, this angle is what? This angle is what, my dear? This is what remains theta. Student, behalf of this angle, let us suppose I'm considering h. H is what, beta? You can say parallel to G effective. This is, student, I found, my dear. This is what, my dear? This is basically beta G effective, right, beta? So this is, student, I'm considering over here one situation here. Let us suppose this is H, and this H is what? Basically G effective. Parallel to what, my dear? G effective. I'm calling beta. You can see this is at point A. This is what, my dear? Basically, I'm calling point A. Okay. In fact, this can enlarge here. Then I'll use same concept everywhere. Okay. So beta, this I can say from free surface. Listen carefully, beta. It's a highly good point, beta. Rarely I can say discussion happen in the classroom. This beta, this entire length beta, I'm considering H. This entire length beta, I'm considering H. From point A to free surface length is what? H beta. And H is what? Parallel to G effective. Student, I wanted to write what is the pressure at point A. What is the pressure at point A? No, student, this is open to atmosphere. So we can write here. This is what P naught. This is what P naught plus beta. This is what you can say rho H. And what is G, bacha ji? Here, all of you, just now I found. What is G over here? This is nothing but what you can say, beta, root of A square plus G square. So this is when you can write pressure at point A. Keep in your mind, H is what? Parallel to G effective. H is what, my dear? Parallel to G effective. So this is what? Pressure at point A. So you can just think more about these questions. How? Beta, have a look next diagram here. Let us suppose, beta, you can just think pressure A, you can find at different base as well. Students, you can say for these situations, sir, at point A, this is the, students, you can think, student, this is the liquid. This is what, my dear? This is the condition of liquid. So student, I'm considering at point A, this is point A, beta. This is point A, and this is what, my dear? This is S basically. So student, point A, I'm considering here, which is L1 distance in vertical direction. What, my dear? L1 distance in vertical directions. Now students, I'm considering here, this is L2 distance or point A. Point A is what? Under the water, L1 distance. Point A, students, you can take, you can say L2 distance from, you can say beta, this condition, right? So student, L1, L2, I can say, there are little changes here. This is L2, right? So student, little changes, so I'll just, yes, this is student surfaces of liquid. This angle is what, beta? As usual, free surface. You can take theta. Listen to me carefully, beta. This is a highly important point, bacha. L1 is what? You can see vertical distance from point of point A. L2 is what? Horizontal distance of point A. That's all. Okay. So here, beta, I wish to write like pressure at point A for L1. Pressure at point A due to L1. Right, beta? So I can say at pressure at point A due to L1, beta. What you can write? This is P naught plus beta G. This is, tell everyone, this is density, beta, rho L1 into what? G. Simple beta G. Rho G is near. We remember rho G is process due to liquid. So this is what you can write bacha G. But now student just you can equate something here. L1 terms. Beta what I can say? L1 terms, right? So L1 terms beta how can you replace it? Students for replacing L1 terms, what you can take? Student this is what you can see theta. Student just draw perpendicular. Student you need to draw what I can say perpendicular. Student if we'll draw perpendicular then what you can say? Student just listen carefully here everyone. This is theta beta, this is 90 degree, this is 90 minus theta, this is 90 bacha, this is 90 minus theta. So what you can say, this is remains theta, this is 90, so this is what 90 minus theta. This angle is what my dear? This angle is you can say 90 minus theta. This angle is what beta? Remains theta only. This is what you can see remains theta only. Now student just take component of L1. Just I'll make diagram here bacha for your better clarification. This is students L1. This is my dear H. No, physics point I'm working beta for your goodness only here. So here I'm not just doing job, just syllabus completion. No, not at all. Only I wanted to convey the concept each and every students can feel comfortable at physics point. Students know this is what basically theta. I hope you got the point. This is theta beta, again I'm repeating here. This is theta beta G, this is 90, this is 90 minus theta, so this is remains theta, this is also 90, so this is 90 minus theta, so this is theta. This is what beta G? 90 minus theta, so this is what again you can see theta. This is what beta you can see again theta, right? Okay, student this you can take component of L1 bacha. L1 cos theta, L1 cos theta, what beta G? L1 cos theta is equals to what bacha? L1 cos theta is equals to H bacha, both are parallel. You can write my dear, this is L1 beta G cos theta which is equals to H. You can write beta G, L1 is equals to what? H time of sec theta. L1 students you can write H times of sec theta. So how can we find theta? So student just we go through here once. This is the formula which already we have done. What bacha? You can say sir this is what basically A. And this is what my dear? G. And angle is what students? From vertical. This is what theta. Just tell me everyone here. Tan theta from here. This is A by G. Tan theta we know everyone. This is A by G. If we have a tan theta beta, just tell me what is the sin theta I can write bacha from here. What is the sin theta beta G? This is what you can say perpendicular. This is beta what? Tell me everyone. Perpendicular one hypotenuse here. So this is you can say A upon root of what beta G? A square plus G square. Now bacha, then students I can say you can write similarly beta from the same triangle cos theta. So what is cos theta here? What is cos theta my dear? This is base beta G. So you can see this is G upon root of A square plus G square. This is cos theta. This is what my dear? Cos theta. So student, I'll use beta this concept over here. So you can write my dear L1 is equals to H upon G. Beta this term will goes up here. So this is what my dear? You can say A square plus G square. So this is student I can say L1. This is what student I can say L1, right beta? This L1 you can feed over here. You will get pressure at point A in terms of this bacha G. So student I'll put this value of L1 in this equations, right? So, student you can take snapshot. I want you to turn the page my dear. Okay, now students I can say what is pressure at point A beta? Pressure at point A bacha? Tell everyone. Pressure at point A. Okay, students, pressure at point A. This is P naught plus rho G L1. L1 we already found beta. L1 beta how much here? This is beta, you can say h upon g, and root of beta, this is a square plus g square. Student, this value we can fit over here with Chachi, right? So students, what is pressure at point A, which is P naught plus rho g, and L1 beta g, this is h upon g root of beta a square plus g. You can see beta g cancel. So you can write pressure at point A, P naught plus rho h into beta g a square plus g square, a square plus g square. So this is the pressure at A. Also, student, already I found this is also pressure at A. So in the paper hall, you have to just be conscious, be careful which formula we have to apply, what they are asking. You have to respond pressure at A according to demand, because if you want to find pressure at A due to this H, then this is the formula. If you want to find pressure at A due to L1, then beta G, this is L1 beta G. P naught plus rho h root of a square plus g square. Now student, here we wish to find pressure at A due to what beta G? I can say L2. Right beta, pressure at A, what we can say, this is what, due to L2. So students, this is in vertical direction bacha party, this is pressure at A, you can say bacha, due to horizontal length, due to student, you can say horizontal length, which is L2. What my dear? Horizontal length, which is what my dear? This is what? L2. I'll just make turn here. Okay, fine. So here bacha, you can write here again P pressure at A. What bacha ji? This is P naught plus. Student, already I proved here. Here student, already I proved this case also. This case also. Pressure difference in a what? Accelerated fluid in horizontal direction. So I'll use beta. This is rho LA. So beta, for this condition, I'll use beta result as usual directly. So this is what my dear? Rho L2 into A. Rho L2 into A. Students, again here, I'll make, I wanted to find L2. So for getting L2 beta, what I can say, this is, I hope all of you remember. This is, student, I can say H. Right, my dear? This is, students, I can say free surface, which is equals to theta. This is what, my dear? L2. This angle is what beta, you can say 90 minus theta. This is what, my dear? 90 minus theta. So here again you can take component here. What? L cos 90 minus theta. So L cos 90 minus theta, beta, what we can say here? This is beta, just take component L cos 90 minus theta. Students, L cos of 90 minus theta is equals to h beta. You can say L of sine theta is equals to s beta g. So here you can say bacha, L is equals to what? H time of sec theta. In fact beta, this is L2 my dear. This is L2 beta. L2 is what? H times of sec theta beta. Okay. So again I can say beta. Here we found in previous cases, that is what my dear? Sine theta. So this is what beta? Sine theta is, tell me. This is A upon root of what, student? A square plus G square. Right, my dear? Already I approved, students. My dear student, all of you, welcome at Physics Point. I'm very happy to see all of you has all of your dedication, student. Till now, night around 1 o'clock going to finish, and you are in the live session. All of you, welcome it and stabilized. So here, student, already I found this is sine theta and cos theta beta from here only. So students, sine theta here. So already I wrote, my dear. So L2 you can write with here. So what is L2? You can say H upon A, and beta, this goes up na beta. This is, students, A square plus beta G square. So you can write this is L2. This is what, my dear? I can say beta G L2 only, right? This L2 beta I can fit over there. Then you will get pressure due to horizontal length. With respect to what beta I can say? Free surface, my dear. So L2 beta. Have a look here, everyone. Pressure at A. What beta ji? Rho naught. This is P naught, my dear. Rho L2 into A. So pressure at A beta L2 already be found. So this is P naught plus beta. This is rho. This is A H upon A into beta G. This is G square plus A square. You can see A and A finish, my dear. So you will get pressure at point A. How much bacha ji? P naught plus rho H. What student? G square plus A square. So student, keep in your mind, these all are highly important, my dear. These all students are literally highly important, bacha ji. Keep in your mind, I gave pressure at A. There are three formula. I gave a student pressure at A three formula. This is student first formula, I can say pressure at A, which is I can say with respect to height. Pressure at A due to length L1, which students I found over here, right? Pressure at A due to L2 beta. So this is already I give three formula at pressure at A only. What, my dear? At pressure at A only, right? Students, now I can say further beta ji. You can also take consideration, students, one more case is what, my dear? One more case is beta. Pressure distributions in a closed container. What, my dear? Pressure distribution in a closed container. What beta? You can see in a closed container. Okay, fine. So student, already I give the formula, but this little students I can say the things which you can take for consideration. This is a container, student. Now I'm going to give you concept of, I can say, pseudo force. That's why I'm repeating this one. Otherwise answer remains same, bacha. This is a container which is filled with the liquid. My dear, this is a container which is filled with a liquid. So student, no, A is what? Acceleration of container. A is what, dear? Acceleration of container towards right only. Students, let us suppose I'm considering here a point A, which is you can say at a depth H, right? And this length, students, I'm considering L. This length beta I'm considering L. Okay, rho you can take a student. Rho is what? Density of water. Now student, I can write pressure at point A. This is what beta? You know, P naught. You can write P naught, but there is no, because it's a closed container. You can write beta as P naught, but you know this is the closed container, bacha. So there is no such effect of this. Then bacha ji, what you can say? Plus pressure due to liquid. Plus beta, this is due to pseudo force you can take. Now student, you can take for consideration here pseudo force. This is what? Rho LA, right, bacha? So what is pressure due to liquid beta at point A? This is rho GH. So pressure at A beta, you can write this is, because P naught is equals to 0 for a closed container. P naught is equals to 0 beta, what you can say for a closed container beta G, right? So this is rho GH plus beta, you can say rho LA. This is what? Rho LA. So just you can take in consideration, bacha ji, if they can ask this kind of format, then you have to use this formula. Otherwise, if your fluid motion in horizontal, then you can take rho LA. Then you can take rho LA. No disturbance, I can say issues at all. Now students, I wanted to just just continue next. So student, you can take snapshot. You can take, my dear, snapshot. Okay, fine. So now students, this is the cases which I have done. Pressure, you can see for if fluid is in motion in horizontal as well as vertical. Students, also you can think pressure difference in a rotating fluid. Now students, state physics point beta, state physics point here, Not only just I'll come to the syllabus, I'll try to put in your mind as well. Listen to me carefully only. So what is next? Pressure difference, student. This is pressure difference, in rotating fluid beta. Pressure difference in what beta is? Rotating fluid. Pressure difference in what, my dear? Rotating fluid. Okay, so students, you can take for consideration as an assumption. Let us suppose you can take tell a student this is the axis of rotation. This is what, my dear? Axis of rotation, about which you can say, student, this is what? Omega. Did he value my love? Not I can say value. Electric field lines never intersect each other. Two electric field lines never intersect each other. It's true only because at the single point there are two possible directions, which is practically not possible. So it's true beta. Now have a look, student. Pressure. What's what I want to discuss, beta? Pressure difference in a rotating fluid. Now, students, you can say this is what, my dear? This is you can take care as a students. Right. So here you can also say either beta you can say pressure difference in a rotating fluid, or you can say, my dear, you have to find pressure as a function of x. You can also tell a student what pressure as a function of x. Right. So student, this is omega. This is, I can say, a container which is filled with a liquid. This is a container which is filled with a liquid. Right. So no, this is a concept I hope all of you know very well. Very good concept you have. Student, I can say, student, for this condition, if there is a linear variation, what, my dear? If there is a linear variation, then what is the culprit of to start the question? What is the main part of the question, my dear? You can say for that conditions, you have to move x. What, my dear? You have to move x and take element dx. Student, this is a very, 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 very useful point. So you can keep in your mind. So you can keep in your mind. If there is a linear variation, then what is the first step? If, you have to move x and take element dx, my dear. Okay, so you can write over here. There is a pressure difference. There is a what, students? Sir, for me, rotational motion very hard. How do I fix it? Student, stay at physics point. Now, just when I'm taking live classes because of student request. If you want any of the physics topic, sir, I wanted extra guidance, I'll give you. I'll avail the classes. If I'll get free, I'll update on YouTube only comment section. You can write your comment concern in comment section. Any I can say under any video, I'll back to you. Right, as according to my availability, I'll arrange class for you. Now till night, I can say I'll take classes. I'll finish today entire accelerated fluid with numerical as well, means and advance both. Right. So if you want extra guidance, then you can write your concern b.sarma9219 at the rate of gmail.com. I'll get and back to you. Right. So now, student, you have just moved x. This is the first step, students. You have to move x and take element dx. Now, my dear, this is pressure here. You can say this is the pressure P. But here, student, pressure will more. So here, my dear, you can write this direction. Pressure is what? I'll write here, bacha, for better understanding here. This is, student, which I have taken element, right, beta? So towards left direction, what is the pressure, student? This is P. Okay. No, it's fine, my dear. You are most welcome. I'll always looking help for each and every candidate who literally wants to do IIT, right, beta? So this is what, my dear? P plus TP. Beta, this element towards right beta, this is P only, and left beta, what you can say, this is what? P plus TP. This is beta, you can say pressure difference. But now you can say, sir, I have taken element. Sir, this is element. So we must write what is length, student? you can see this is dx. So what is length beta g? What is the elemental mass? You can say, sir, we must write elemental mass. This is what, my dear? Elemental mass, which is nothing, sir. This is dm. This is what? Dm. Beta, I hope all of you know. Dm is what, beta? Mass ne yaar. You can again apply, beta. Density into volume. Density into volume, beta. So this is what? Liquid versus in the container, beta. This is remains rho, beta. You can take. And A is what? Area of container, my dear. Okay. And what's the length here? This is my dx. So you can write, students, dm is equals to what? Rho a into dx. Rho a into dx. Students, I hope all of you remember, my dear, in circular motion. In circular motion, we have a two acceleration. Student, in circular motion, we have a two acceleration. One is what, my dear? Radial. One is what? You can say tangential. So now, students, you can say radial is responsible to avail what? You can say bacha, centripetal acceleration. So you must write, my dear, what is AR? What is AR? Student, just I'm writing one time formula, student. AR is what? This is omega square r. I hope all of you remember. I hope all of you remember. So here, student, I am writing this is acceleration AR. And what is radius over here? X only. So you can write, my dear, this is omega square into X. AR is what, beta g? Omega square into X. Okay, fine. Now, beta, using concept of NLM, students, now because everything we found, pressure is there, just multiply by force. Pressure, beta, multiply by area here, not force. I said wrong. My bad. Sorry. Now, bacha, this is the force, bacha. So, student, again, here I'm going to use using student. This is concept of NLM. What, beta? Using concept of NLM. So what is the concept, my dear? Summation of F net, which is equals to ma. Now, beta, I can say, sir, this is a more force, this is a less force. So you have to do, student, this minus this, because you know, beta, driving force. So you can write, my dear, this is P plus, beta, dP into A minus beta g. This is pressure into area. Is equals to what? Beta, this is not MA, DMA, you can say. Right, beta? So what is GM? Already we found, right here. Rho A into dx. And what's the acceleration, student? This is omega square into x. Now we can see this A, this A, this A, finished. So what you can say? P plus dp minus beta g, you can see p, which is equals to rho omega square x into dx. Now, beta, I can say this p, this we finished. You can write, my dear, dp is equals to rho omega square x into dx. dp is what? Rho omega square x into dx. Now, students, we wish to find what? Pressure difference. Integrate both sides. Simple. And what's the? Either they can tell student pressure difference in a rotating fluid, or they can say, find pressure as a function of x. So don't be hesitate. Both are same questions. Both are same question, beta. So this is what, beta, I can say dp. So student, just integrate both side, my dear. So this is dp is equals to what, beta g? Rho into, beta, omega square x into dx. Just integrate, beta g. 0 to x. This is what you can say 0 to p. Right, beta? So finally you can say this is what? Delta p here. You can see, beta, this is delta p. And what's a what? This is rho omega square x square by 2. So beta will get, this is what? You can say delta p. In fact, beta, it also, you can't say 0 here. No, because this is what? Touch with atmosphere bacha ji. So you can take, my dear, this is p naught logically. You can take, beta, p naught here. Then you can write, this is what, my dear? This is dp. So keep in your mind, this is pressure difference due to what? Rotating fluid as a function of x. Rho omega square x square by 2, right? But students, I can say here, beta g, here you can say for delta p, you can again categorize two things. Beta what? Plus rho omega square x square by 2 and बच्चा जी minus rho omega square x square by 2, right बच्चा जी? So when will get plus and when will get minus बच्चा? I'll tell, right बच्चा? Just take snapshot my dear. I wanted to turn the page. I hope you have taken. Fine. Now students, have a look next. Bacha, what we got as a result here? Pressures in a rotating fluid versus delta P. What beta? Rho omega square x square by 2. This is when we got, I can say, bacha, change in pressure or pressure difference. Now students, everyone we remember here, MR. MR is what, students? Right, most remarkable beta, right? So student, delta p can write beta ji, delta p can write rho omega square x square by beta g 2. This is delta p can take what beta, moving away from what, rotational axis. You can say beta, this is delta p can write if you are moving, this is what you means, you can say a container beta, moving away from what, away from the rotational, away from the what, rotational axis, as a what beta, as a what, you can say pressure increases, as a what my dear, pressure increases, pressure increases. No, so you can connect here like as I said na, delta p is what, rho gh, if you are going what beta, down to earth, right? Depth. So same thing beta, I can just say this one also, plus is what, rho omega square x square by 2 if you are what, moving beta what, again away from the rotational axis. Now student, this is, I can say MR2. This is most remarkable beta g. What bacha you can write over here, delta p is what, because this is in reality beta, plus minus rho omega square x square by 2 minus rho omega square x square by 2 bacha. This is, you can say delta p. If you are moving what beta, towards, this is away, this is what my dear, away, for away what you can write, rho omega square x square by 2. But if you are moving beta g towards, if you are moving towards of what, towards what beta, you can say towards of a rotational axis, towards of beta rotational axis. Okay, then beta you can say what, minus rho omega square x square by 2 beta g. Simple here. So these are the, I can say, result which you can keep in mind for rotating fluid. So there is one more, I can say syllabus already finished beta. I'll do only numerical here. I'll do only numerical, right? So now student, I'm going to do numerical. I can see it's a demand of one candidate. I don't know who is in currently in live session or not. Shubham wanted numerical of JEE mains. Now Shubham, I'm going to do numerical on JEE mains, right? Okay, might be Shubham is present over here. Shubham, are you present currently in live session? Okay, fine. So this is, I can say, question here dedicated to Shubham. Shubham wanted numerical based on JEE mains. So now I'm going to do here. This is JEE mains beta g PYQs. This is JEE mains beta. I can say this is PYQs. Okay, ask beta. I can say this question asked by multiple time. Student, this question asked by JEE multiple time, not a single time, my dear. Right? So no, student. Again, I can say for this question they can ask multiple things. They can ask multiple things. Find relation of x and y of free surface. That is fine. Or beta, I can say a liquid of, just I'll write beta Shubham. So beta, just I wanted to give you a complete statement of questions. What questions, student? I can say I remember a liquid. So beta, a liquid of density, a liquid of density rho is rotated, an angular speed, and with a angular speed omega as shown in the figure. You know, student, now just I'm writing in live session. I can say normal class or physical class. I never appreciate to write. These are the, I guess this is the time pass only. But just I can see normal classes. I just give the like direct diagram. So student, you can just think better like this. This is the container. This is the container. Now students, you can say this is students, no, this is a practical thing here. Maybe I can say when if it was like 5 or 6 years old, right, that time I can say maybe he was doing, I don't know about you, but I did a lot. I did a lot. Now but I know this is, you can very simple here. You can take glass of water, right? You can take glass of water and do finger like this, do like this, right? But if we'll do finger like this here, then what you can analyze, so you can feel my dear, this is the shape of water surface. This is the shape of water surface. Now you can realize when you was, I can say 5 and 6 years old, not possible for you. Now you can realize, my dear, this is what beta condition. I can say final surface, final shape of free surface. So now students, you can say everywhere. Either they can ask what is the coordinate at this point. As I said, you can also find equation of what beta. You can also say bacha, like another way beta. This is a question session bacha. Again beta, I can write another question statement. Find equation of, find beta what I can say, find equation of, find beta the equation of free surface. Find equation of what I can say free surface. It's been do here. I'll back beta within. Do question, student, everyone. I'm giving you 30 seconds. You can try. Then I'll do this question beta. It's a very good question here. JEE students repeated this question multiple times. JEE student repeated this question multiple. Uh, Anyone from all of you, can you answer me beta? Anyone from all of you, can you answer me this question, please? Shubham. Okay. Should I do? Okay, beta. Come. Come, bacha ji. Beta, what's the question? Find equation of free surface. Right, beta? So this question, what? Student, you can take. Again, consideration. This is, beta, you can write variation in both. Student, you can take what is the coordinate at this point? X comma y. So student, just I'll make a video of this surface beta here only. This is FVD of students, I can say free surface. Students, FVD of free surface. So now students, I can say this is the FVD of free surface beta. Students, you have to move X and take element dx. Student, you have to move X and take element dx. Right beta? Okay. No, if you have taken element dx beta, then what you can say? This mass is what? Students, you can say this is dmg. Right here. Okay, beta, if any particle which is revolving on a circular path, because already mentions there, particle is what? Rotating with beta angular speed omega. Right, my dear? So for this condition, what you can say? Because centrifugal force always acting, my dear, away from the center. Centrifugal force always acting what? Away from the center beta. So this is, you can write, my dear, this is d m omega square. This is, what's the radius beta? This is x only. Now we can say, sir, these two are 90 degree. Now we can say, my dear, these two are what? 90 degree. Right? If these two are 90 degree, bacha, so let us suppose I'm considering this angle is what, my dear? This is theta. So this is 90 minus theta. You can say, dear, this is remains theta. You can take student component of this dm. So what you can write? This is dmg cos theta. Now students, you can say this is dmg sin theta. So now we can take component of beta, this one. So what you can say, bacha? This is dm omega square x, student. This is what? Cos theta. Student, along tangent, student, thus equate these two forces. You will get some relation from here. So students, along tangent, you can equate the forces. Student, along the tangent, what bacha ji? dmg sin theta is equals to what beta? dm omega square x. Student can say dmg cancel. This is, student, you can write sin theta beta cos theta this side. So this is what, my dear? Sin theta by cos theta, which is equals to omega square x by g. Right beta? And all of you agree, sin theta upon cos. Can I say, bacha, this is tan theta? Sin by cos beta. Can I say tan theta, bacha party? Okay, you should take snapshot. I wanted to turn the page. Okay, so now, bacha, you can write tan theta is what? Omega square x by z. And tan theta is nothing beta, it's a slope. So you can write this is d by dx is equals to omega square x by z. Now students, just apply concept of variable separable. Students, you can apply concept of what, my dear? Variable separable. So this is d by is equals to what, my dear? Omega square by z into x dx. Beta, just to integrate both side. Integrate both side beta. So what you can say? dy becomes by, which is equals to omega square x square by 2g. Omega square x square by 2g. So student, this is the answer of this question. So we can write what? Equation of free surface. So what is the equation of free surface beta? Just be, no, student, here I'm explaining bit of the point, because we are in live session, so you can understand the thing beta. This is, now time around 1:20 still. you are here and I'm teaching you. I'm feeling proud on you, beta. So this is equation, beta. I can say for this thing. After this, beta, I can say just I'll do numerical, right? So this already, beta. I can say you asked me this question, so already I said, right? So beta, just do the first numerical here. So beta, what is first numerical, beta? I can say I'll write beta questions here. I'll write student complete questions. What's the question? Yes. And what beta see? Open a cubical tank. And open beta, I can say cubical. Now student, I'll do only beta. Theory finished. I'll do only numerical beta. This is the beta numerical. I can say kind of beta. Not I can say approach a little like advanced beta. And open cubical tank completely. What beta I can say completely filled with water. Completely beta filled with water is kept on a beta z horizontal surface. Kept on a what beta horizontal surface, right? Its acceleration. It's a student just go through diagram here. Just now student I'm mentioning thing in the diagram. Bacha will take time here. Figure shown. Simple bacha. What I can say figure shown. Student you can take. This is already student. This thing we have done. It's a good question, beta. Ask why JEE means. Beta, this is a container. This is what, my dear? Container which is filled with liquid. Which is what, my dear? Filled with liquid. Full air. Completely. Say beta, completely. Now which I can take this length is also 1 meter beta, and this is placed on a beta horizontal surface. Already mentioned here. This I can say beta, this base length is also remains 1 only. Now this is beta, I can say system is motion in this direction. A beta I can take what? 2 meter per second square. A beta what I can say 2 meter per second square. Beta what we wish to find here, right? Find the mass of water that would spills out of the tank. Literally it's very common beta. Very common questions here. Find amount of water. Find beta amount of water that would spills out. That would spill out of tank. Spill out of tank beta. Okay, very good question here. Very good question, Majapati. Now, student, what you can say? If acceleration of a container is A, then beta what angle of free surface B? Remember everyone. Easily we can find. So beta what we can write? What is the amount of water which spills out from the tank? So Bachaji, this will go through your solution. I'll write over here only. Diagram again I'll make here. Right? Beta same questions. This is what questions here. We have to find amount of water which spills out. Student, this is a container, right? This is beta completely filled. Just you can take in consideration beta completely filled. This base beta what you can say 1 meter, my dear. This is remains student you can say 1 meter. What is the this is beta acceleration here 2 meter per second square. This is what, my dear? 2 meter per second square. We have to find amount of water. So now beta I know everyone. Sir, this is a initial surfaces, na? But system is what? Acceleration. System has a what? Acceleration towards right. So what you can say, bacha? You can think like that here. Sir, this is the final condition of water surface. This is what, dear? You can say final condition of water surface. So student, simply first you can find here this theta from free surface. So what is theta, bacha? I hope we remember here. Now I proved the result. This is what tan theta. tan theta is what, my dear? This is A by G. Now, bacha, so what is A here? You can see this is 2 by 10. G can take 10, bacha. So finally we'll get what? Tan theta is what, beta G? 1 by 5. Uh, oh, very good, Aryan Mishra. I'm happy to see beta. Very good, Aryan beta. Very good, bacha. Tan theta is what? A by G. Very good, bacha. Aryan, when you joined beta? Aryan, bacha, when you joined? Aryan, my dear, when you joined beta? Aryan, bacha, when you joined? Newly? Okay, very good. You are loving beta. Tan theta with A by G, bacha. Now, bacha, let us suppose we don't know what is the value. You can take beta G as a consideration. So, this much I can say X. This is the what? Value of X beta. Or you can take bacha, this is the Y. This is Y, right, bacha? Okay. So, beta, you can see for this condition. Sir, we can equate tan theta we have. So, we can use beta again in principal here. So, you can say, bacha, this is what? Tan theta is what, beta, you can say? Tan theta, you can also write a beta Aryan. This is by 1. And this is already be found, bacha. What you can say? 1 by 5. So, finally, beta, you will get y is equal to what, beta? 1 by 5. Y is 1 by 5 means you can see, beta, this is what? 0.2 meter. This is what, my dear? Basically 0.2 meter. We wish to find what is the volume of water that spills out. It's given as simple, bacha. What is volume here? Volume is what, beta? We wish to find volume of water. This is what, beta? Volume of water, you can see, bacha, this is, that is, spills out. That is, spills out here. Simple, we can find here. Volume is what? Area into length. Simple. Finished. What is area? But it's a triangle. It's a triangle, my dear. Na Aryan, bacha. Oh, just now, Aryan. Okay, okay. Where are you from, Aryan? Where are you from watching? Okay. Fine. Sir, I gave JEE means I have attempted 45 questions, 21st second shift. How much I can expect? Okay, you welcome, you welcome. I can say, bacha, 45 questions. Aryan, bacha, nowadays, already student, I solve all the questions. I already uploaded all the questions with a solution. But Aryan, it's a memory-based questions. So it's Aryan, tough to guide you exact percentile, right? Better way student, I can tell you, because now today I asked many students during live session beta. I can say today also I was live. So many students asked your queries like you. So beta, I can say 45 questions beta ji. So do you have any confidence ki out of 45 all questions are good only, correct only beta? Aryan? Okay, it depends with, I can say, 21st and second shift. I have to check what's the level of question basically. So then I can tell Aryan, bacha, right? Aryan, but I give some time, bacha, at least 1 to 2 days. Just once finish means examinations. If I'll receive a paper from NTA student, then I'll tell you, beta, I can say exact guidance. Now, beta, what is volume, bacha, party? Area into length. So, what is area, bacha? This is area of triangle. So, you can say half into beta ji base into beta height into L, bacha ji. So, half, bacha ji, and base beta how much? This is 1 only. What is height, bacha? This is by beta how much here? 0.5. Okay, and what's the length, beta ji? What is the length, bacha? This is length remains 1 year. So, now, beta, what we can say? This is beta 1 by again here 2, no? So 1 by 4. Beta how much coming here? Till bacha body? This is what I can say on 1 by 4 here finally. Because this is also 1 by 2. This is also, bacha, you can see 1 by 2, bacha, right? So half into base into height. Half into base into height into 1. Correct only, bacha. So this is 1 by 2. 1 by 4 no beta 0.5. This is beta, I can see meter cube beta. Aryan, you didn't respond me beta. How many questions you have a confidence? You have a confidence, bacha. Oh, I have a wrong taken here. This is a 0.2 basically. This is 0.2 beta. So what's answer here? You can see 0.1 meter cube. Student, this is answer for the question. Okay, now student, have a look next year. Question bacha party. I hope you enjoy Aryan. Okay, Aryan. Okay, I got it. Yeah, sir. Maximum 2 to 3 question will be incorrect in test. I always maintain. Oh, very good, with Aryan. I have attempt 23 in physics. 21st beta, Aryan. Okay, 21st maybe solution is here. I can say. Aryan, give me beta seconds. Aryan beta, give me seconds. I'll give you beta. Aryan beta, good here. Literally, your result will be good beta. Give me seconds. I can check once. Where is 21st solution? I'm not getting where it is. 21st. 21st beta, which shift your shift name is what? Second na? Okay. I can say beta expected according to your beta, I can say 23. Expected percentile beta above 97 beta, 95 to 96 to 97 aggregate. In physics beta, I'm pretty confident. Beta, what you said, Aryan bacha, 23 questions, so I'm expecting 20 only, right? I'm expecting 20 only, bacha. So your percentage percentile beta almost 96.5 to 97.5, like that, bacha. In physics beta. In physics, bacha. This is literally I can say expected, and you can do bacha, because now just you join and immediately you responded me. Sir, tan theta is nothing but it's a by z. So literally you have a potential. You can do bacha. You have potential beta. You can do these kind of questions. No need to worry about it at all. Now, bacha, have a look next question here. Beta, I can say this is again here very good questions. Kind of advanced. Kind of beta, what you can say? This is again here advanced questions. Bacha ji, there is, I'll not write, I can say, Aryan bacha, okay. Sir, can I get 100% in physics in second? Yes. Aryan, I'm telling you one story. For literally, you will motivate. Aryan beta, in 2024, in fact, beta, my mobile got erased. Otherwise, I can show you, bacha. Aryan beta, in 2024. Right, bacha? Previously, beta, I was working somewhere. So, I can say, bacha, my one classroom kid, Aryan beta, my one classroom kid in 2024 secured 100 percentile. 100 percentile beta. In session 2 only. In session 2 only beta. In session 1 beta, I can see this Y beta aggregate secured 99.7676 like percentile. In second attempt beta, my kid, classroom kid, secured 100 percentile. I can say beta in section 1, full score 80 marks. In sections 2 beta, full score I saw. This is 20 marks. So you can do beta. Just stay tuned at phase 1 beta. Stay tuned at phase 1 because now I can say once means you will finish, then I'll start one tablet course. Student, then I'll start one tablet course. In that tablet course, I'll make a batch like good percentile, good student, good what's your current result. According to result beta, I'll make let us suppose you are pretty confident in concept. Let us suppose the student Aryan, you are pretty confident in concept. For this kind of student, I'll only do practice session of numerical. Because now you know, just now beta, I finished Aryan entire accelerated fluid concept. What is the maximum extent? You can go for Pan India. Student, you can go for Pan India. What is the maximum content available? I explained all the concept. Now I'll do only numerical. Now I'll do beta only numerical here, right? So this is a student already. I can say I solved two numerical beta. I can say this is one. You already responded with party. This is two numerical. These all are I can say beta based on accelerated fluid. Now beta, this is question number third. This is question number third beta. Aryan, stay tuned beta. You can do. You can do beta Aryan. You can do beta. There is no doubt at all. Now beta, what's the questions? So, no, there's I'm not giving beta. I can say like entire theory here. I don't have much time. Sir, do I have to do any other material PYQs of 20 years are done? Yes. You have to do. You have to do. Beta, what you will do? I can say, beta, first you can do bacha single correct. Listen carefully, beta Aryan. This is single beta J, single correct advanced PYQs. First you have to do beta single correct beta advanced PYQs. Now student, I can tell you what I can tell you student about this boy. Finally beta, this boy got rank in advance 3103 beta or 3203 like that beta, right? 3 yes beta 3103. I'm not pretty confident bacha, but 3000 plus beta, 3000 plus beta. He got finally beta IT Roorkee beta. This boy got IHA Roorkee beta. This is electronic communication engineering EC beta. Aryan bacha, okay, there is one more candidate who is the stone sir. Okay, fine. Beta, do one thing. If you are good enough in physics, literally maths will be good only. For chemistry beta, I can tell you, do beta one thing. Do beta one thing. For chemistry beta, I can say, beta, you have just make grip of physical chemistry first. I can tell about my own story. Student, I can say, what's your name beta? Can you write your name so that I can call you by name? But what you wrote, the stone, this is not your name, maybe. Can you write your name, student, so that I can address you individually? Yuvraj. Okay, fine. Yuvraj, beta, I can say, beta, that is a point. I can tell you about my story, right? Beta, I can say, till now, I'm pretty confident, my dear, in, I can say, like, beta J, physics and maths. Till now, I have I can say phobia, I can say with respect to chemistry. So I can tell you, beta, you can do only physical chemistry. If you have a time, if you have a potentials to remember the things, then student, you can do only and only that is inorganic chemistry. No need to do beta unnecessary organic. Organic it's spending beta, I can say. Organic, my dear, it's spending. Oh, who is flying? Very good. Love. Very good beta. Very good, my dear. Right. So beta will help you, my dear. Right. Beta, for selection in JEE means good rank. It's highly not required to do all subject as a master. No, not at all. Beta, at least two subject you are literally you pretty confident. Two subject beta literally pretty confident. Third year not, I can say topper also you can ask. Third one also not, I can say bacha much, I can say grip on third all subjects. So two subject beta I take a proper grip. Then beta you can do. You'll do bacha. You will do Yuvraj. Oh, Yuvraj, your name. Yuvraj, I can say already I taught one my old student name beta. Now, beta, have look, Yuvraj, question. Yuvraj, you are good in physics, na? Then you can do this question, beta, Yuvraj. Yuvraj and Aryan, both I'm expecting good in physics. Do this question. I'll give you time. Sir, my inorganic and physical is good, but have some backlog and leave it. No need to worry. Leave it, beta. Yuvraj, no need to worry. Yuvraj, just do this question. I'm giving you assignment, Yuvraj and I can say Aryan, both of you. What's question here? Have a look first. Figure so beta, there is a tube filled with, I can say liquid beta, which is L-shaped, right? Now, bacha, I can say Aryan and Yuvraj. Do this question, beta, both of you. Both of you do this question here. Very poor at chemistry. Oh, don't worry, leave it. yes. Yes beta, yes, yes, good argument sir, good thought यार. So student I can say this is beta L shape. Else, you can see beta this is a liquid. It's a good question. Literally beta, it's advanced design only questions. It's a advanced design question beta only. There is beta I can see in L shape of you can see like container. There is liquid nature is student remains uniform my dear. Liquid nature student this is remains uniform my dear. Right. Okay. Now students you can say beta this is mentioned here. You can take beta this is remains H. This length student this is L. Now student I can see this L shape of container motion in what a meter per second square, right? Find beta acceleration for which no liquid will fall out of tube from any end of the tube. So beta what is a, you need to find bacha what is the minimum value of a so that you can say liquid will not spills out. That is question beta. I'm giving you beta. I can say I'm giving you Aryan and I can say Yuvraj. Beta more than 1 minute. You can do these questions. Time will start now. You can do this question, Bati. I'll write question here only. Find value of acceleration. Now value of acceleration for which no liquid for which beta no liquid will fall out of tube from any end. From any end of tube. Right beta. This is question beta. Do beta Aryan and I can see Raj. All of you can do here. There are I can say 8 members looking. Okay, sir, do you teach in any school or Hari no? Why you are asking this kind of question, beta? Hydrostatic pressure and pseudo force should be balanced. Yes, Yuvraj, you can think like that. Night here 1:43. What you are asking questions? Are you retired? Literally not here. I'm 25 and 30 years old only. Why you are asking this kind of stupid questions? Now what's party? Do beta. Oh, sir, my organic chemistry is too big. Okay, leave it now. Why just do questions only? Okay, now student, I'm doing. Yes, beta, you, Aryan Bacha, can you give me some clue? Like Yuvraj gave me something. I can say, bacha. Chemistry is a ranker, yaar. This is a true. Chemistry, beta, I can say boosting subject, boosting of the rank. That is true. Don't worry, beta. Do best, do hard work, right? Aryan, bacha, should I do these questions? Aryan, beta, should I do these questions? If you will allow, then I'll do beta this question here. Beta. Aryan, sir, at the junction of a part, we can equate. Yes, you can think. Okay, very good, Yuvraj beta. Correct. You can think beta. You can think beta. There are two approach beta. Which you said beta. I can say Aryan. You also correct. Beta. I can say Yuvraj said also correct. But I'll beta just consider both of you thought. thought in a different method. So now I'm just first using, I can say, thought of Aryan. Aryan said, this is method 1 beta. Aryan said, sir, at the, I can say, bracket column, we can equate the pressure. Yes, beta Aryan, you can think like that, right? But I can say, how? Because system motion in this direction there. Just beta make ABD of this statement, this scenario, L shape of container. Student, you can take L shape of container beta, this is a condition, right? So student, this will go through once. This is, student, take in consideration here. This is what? Pseudo force. This is what? Pseudo force. If we are taking pseudo force beta, what you can see is pseudo force what? Always opposite to direction of motion. Okay, bacha, very good here. Sir, is the answer right? Yes. Aryan Misra, give me beta 30 seconds. I'll give bacha. Maybe your answer correct. Maybe was Aryan bacha correct only beta. So pressure beta due to ATM here. Beta write down pressure in both of the leg. So beta this is height beta what? Aryan bacha. This is H. Aryan beta. This is what Yuvraj? This is L beta J. So beta what is pressure we can write here? Pressure beta this is open to atmosphere bacha. So you can say pressure is what? P naught plus beta liquid pressure beta. P naught beta plus what you can say? This is rho GH minus beta. You know pseudo force here. Just now I finished beta. I can say horizontal if container motion in direction of horizontal bacha party. Already I said the formula. What beta I can say? Minus rho rho L in beta R in S. Rho L beta. This is rho L A is equals to what beta I can say? Pressure ATM. What beta I can say? Pressure ATM only here. Right. So you can write like this beta. Pressure atmospheric plus beta, this I'll write here, this one, plus beta g, what you can say, rho gh is equals to beta, I can say Rn pressure beta ATM plus beta rho La plus beta g, what we can say, this is rho La. You can see this is finished beta. We wish to find beta what? Acceleration here. So this is rho L into A. So you can say beta rho cancel. So this is, you can say GH is equals to LA. Oh, very good Aryan beta. I'm proud of you, bacha. I'm looking at this kind of candidate. Yes. Very good. That's funny beta. You said beta. I already said here, I'm accounting. I can say thought of Aryan. Already I said bacha. This is method 1. This is method 1 beta. Very good. Aryan, I'm proud of you. I have done IUPAC. Chemistry, I don't know, Yuvraj. I'm a tutor of physics only. But I can help you. But just focus on which you already know, which you have done. That is do practice. Be master of this concept. This is method 1 here. I can see this is Aryan thought. Aryan beta, or I can see Yuvraj. Both of you active here till night, 2 o'clock going to finish. Beta method 2 you can also apply beta. Aryan bacha, this is pretty easy. Aryan bacha, this is pretty easy na. Method 2 pretty bacha, what I can say Aryan, this is, we just remember bacha, you can say this is what? Tan theta bacha. We finished that now. Tan theta is what beta? Just now we finished now beta, this A by G. Tan theta is what beta? A by G, right? This is beta, you can say container shape you can take, my dear. You can take beta, this is what? Shape of the container. Now beta, you can take, this is the theta. You can take beta, this is theta. So this is what, my dear? This is what, my dear? You can say H. And this is what beta? L here. So you can write tan theta is beta what? Perpendicular by base. So beta from here you can write here tan theta. This is what? H by L. Equate beta these two tan theta remains same bacha. You can equate by here. H by L is what? A by G. So what is H coming beta? This is A into L by G. This is H bacha. A into L by G. So this is beta. I can say tan theta here. H beta will get right. So beta they I can frame beta multiple questions, right, based on this only. So Aryan, I'm giving you more questions, right? So what's the question beta? because it's a practice session, right, bacha? It's a practice session, so we have to do more number of practice of questions. Where is the book of the PYQs? I don't know. Okay, so what's the question, bacha, Aryan? This is a question basically. Aryan, beta, note down questions. Bacha, I'll again give you data beta Aryan, right? Yuvraj bacha. It is better. Yes, Aryan beta. This is literally very good. Beta, because of you, Aryan beta, because of you, I stated this concept. Otherwise, beta, I have to follow this one only, beta. It's very easy. Yes, beta. I have to follow beta. This is beta. Always bacha in the classroom. Now, bacha Aryan, come to the point. So what beta Aryan, next question here? You can take beta. No, just now beta Aryan, I finished this concept. In fact, I'm just telling beta because you just now joined. Beta, if you have a container which is beta ji rotating, right? Which is rotating by omega beta. So you can write here a pressure difference. This is what beta ji? This is rho omega square plus minus beta. Plus minus rho beta pressure difference plus minus rho omega square x square by 2, right Aryan beta? Yes, so this is basically concept which I have done. Now Aryan beta, I'm giving you questions here based on this. Aryan beta, just move next questions, next page here. Yes, here only. Aryan beta, this is just I gave you beta, I wrote formula because of you only bacha, right? So bacha, have a look beta, this is next year. So what's the question beta? You can take it. Bacha ji, this is density of liquid beta. 10 to the power, already we know here, density of water. 10 to the power 3, this is kilogram per meter cube. Omega you can take beta, this is watt beta you can take 2 radian per second. G beta you can also take here. 10 meter per second square. G you can see, in fact not required anywhere. Beta, what's the diagram here for the questions I wanted to draw? Yes, this is the questions. Yes, beta ji. Now, beta, this entire system is what? Rotated with omega. Student, you need to find this is point A, this is B, this is C. Student, find pressure of A minus pressure at C. What is student? Pressure at A minus beta C, pressure at C. Do you want to try beta? This question, Aryan beta, or I have to do? Length you can also take beta Aryan. What I have to do? Aryan, you can take which? This is beta C, I can say 2 meter. Now, student, you can take something 4 meter. Yes, beta. This is 2 meter, 4 meter. Beta, we have to find pressure at A minus pressure at C. Aryan, you have to find pressure at A minus pressure at C. Yes, beta ji. Just do this question, beta, fast. Okay, Aryan beta, should I do? Okay, you are trying. Okay, do beta. I'm giving it. It's a live session. No, it's a class basically. You can take your time, bacha. Don't worry. You can take your time, bacha. You can take your time, bacha. Buddy, you can do one day definitely good. Already you are a bright student. Now I'm reminding my older student here, that is TC, which I can say he gave me rank last my entire teaching career, very waste time. That is 100 percentile, which already I said you. Aryan bacha here this point bacha Aryan, right beta, this is rho omega square x square. If you are going away, then beta what you can say positive. You are coming towards, then you can say bacha negative here, right beta, because this is the concept Aryan bacha. This is the concept. Okay, Aryan. Okay, 6. Okay, Aryan bacha, I'll do beta. Have a look my solution. Come Aryan beta ji. So what bacha? I'll use beta same formula only, which already I said Aryan. Now beta, you can see beta you are moving from here to here. So pressure what increases, but you will go from here to here Aryan bacha. This is what pressure decreases bacha, right? So beta, what I can write bacha? We wish to find what pressure at PA in solution Aryan bacha. Pressure at A minus beta ji pressure at C. What I can write? Pressure at A minus pressure at B plus pressure at B minus beta pressure at C, right? Okay. Finally, beta I can say from here to here, bacha. If you are going beta this direction, so beta this is increasing the pressure. But if you are going beta from here to here, bacha, this is like this beta, just opposite. Then beta what you can say, this is what decreasing the pressure. Beta here student you can just take pressure increasing, and here what my dear pressure decreasing. Aryan beta, is this clear bacha? Aryan, is this clear bacha? What you have taken this kind of beta like say assumption or something different? So pressure at A bacha, I'll write this is what beta ji plus rho omega square beta into beta ji 2 whole square by 2 minus beta ji, this is decreases pressure. This is what rho omega square, what bacha ji 4 whole square by 2. Omega bacha mentioned here and rho also mentioned. Beta I can take common beta. Pressure at A minus C bacha ji rho omega square 2 to the 4 by 2 beta minus 4 4 the 16 by 2. This is 8 beta, this is 2 bacha. So pressure at A minus C beta, what will you get? Rho omega square 2 minus beta ji 8. 2 minus 8. So bacha I can say we'll get pressure negative here. Aryan bacha, okay, Aryan sir, can we say that in the directions of pseudo 4 pressure always increases? Yes. You can tell beta. It's a concept here. Aryan bacha, it's a concept beta. Aryan bacha, it's a concept basically. You can tell like that. Bacha. Okay, fine. So beta, what's your answer remains same bacha? Aryan bacha, what is bacha coming? Rho bacha how much? 1000. 1000 beta and omega square 2 to the 4 beta, this is what you can see minus 6. So PA minus PC beta 6 to the 24 into 10 to the power beta minus here 10 to the power 3 Newton per meter square. This is it beta. Your answer remains same beta or something different bacha buddy? Your answer remains same bacha or something different? Aryan bacha, your answer remains same or something different? Okay, I didn't get a reply from your side, Aryan. Okay. Students, we have to do here more questions based on this, right? We have to do bacha more questions based on this. Okay, fine beta. You can say bacha pressure difference in accelerated fluid bacha. This is what as I said rho LA. If we move opposite to acceleration, sir, I didn't squared the omega by mistake, but I have written it as okay. Fine. Very good, Aryan bacha. Very good, yeah. Good bacha. I can say, sir, how I'm perfectly fine, student. I'm perfectly fine. I'm doing well. did mistake in subs. Okay, okay. It's but that's why no. That's why I can say better separately. I have taken theory. Now it's better what I can say better entire practice here. Right, but just have a look better next question. Better Aryan questions better will do only Aryan. You have a concept here. Understand? I can say last 10 to 15 minutes you are with me. So I can say I understand what you have potential. You can do very good. For right guidance, I can tell you, for right guidance, definitely will do very best. You will do very best. Right, Aryan? Okay, fine. Aryan, bacha, have a look next question, sir. Aryan, beta, just have a look next question. So what question, bacha, bati? Beta, here you can find absolute pressure. Same question, bacha, Aryan. This is little change. Find, because you did mistake. Otherwise, I'll never repeat same pattern of question, my dear. Find absolute pressure. Find, my dear, find absolute pressure. Find absolute pressure at and B beta. Figure shown. Figure shown, bacha. This is bacha I can say rod, right? You can take beta. This is omega. This is beta. You can take this point is A. Now beta, this point is B. This point is B. This point A beta, this point B. Length, you can take length till beta. Aryan bacha till what length I have to take? Aryan till bacha what is the length I have to take? I'll take your data. This is my habit beta. In the classroom now also, in physical class, I have to ask data from a student only so that he can feel comfortable. Tell beta, Aryan, what I have to take beta? Length of the, I can see this container. Okay, fine. I'm just taking beta. This is, why you putting question mark? 10 meter you can take now. Okay, density of liquid beta, Aryan, you can take beta as usual. This is what beta? 1000 kilogram per meter cube. Aryan bacha, I can say omega. Aryan bacha, till what omega have to take? Omega beta, what I have to take? Yuvraj, where are you gone? Yuvraj, are you there? Yuvraj, are you there? Okay, maybe he is not available. Tell beta, Aryan, what I have to take? Omega. Just data, just I'm asking you, so that you can feel comfortable. You are framing the questions. Okay, 14, you can take beta. This is 14 radian per second. You know beta, Aryan, I can tell you one story. I can say beta, when I was in Kota, right, at an institute. You know beta, what happened, Aryan? Usually beta, Aryan, this is my habit. This is my habit beta to ask data from a student only, so that a student can feel comfortable to learn the concept. Student, I asked beta one data to one boy. You know what he said? I wanted basically mass. You know what's the question, bacha party? Question is this, Aryan bacha. You can say, Aryan beta, this is the block. Mass beta ji 2 kilogram. I asked, just tell me, what is mass? Let us suppose this is block A and this is block B. What is the mass of block B? You know what he answered? He answered, beta. He answered, sir, you can take ln2. Just imagine how ln2 we can take, sir. But still, my habit to ask data from students only. So that I ask you data, what's the rho, what's omega, what's the length, so that you can feel comfortable and you can answer me the question. Till answer, bacha. Beta, we have to find absolute pressure at and B, bacha. Data, you, I can say, bacha. Okay, yes, I know, bacha. Correct only. I can say Prince Huda wrote something. Sir, I start my physics from zero and I start or I started? I started beta, I can write. Sir, you can write beta, I started my physics from zero and I am so depressed. Why? Sir, I have backlogs due to, oh, very bad. Okay, fine. Prince Beta, first you have tell me in which class you are. 11th or 12th. I'll guide you according to your, I can say, class. 11th or 12th. J mains or dropper or advance. According to this, beta, I'll tell you my timing. Oh, 12th. 12th finished or 12th? You are going to 12th class or 12th you will go to write exam? Currently in 12th means you will go to write exam, na beta. Currently in 12th means you will go to write exam, na bacha. In the month of February. Okay, fine. Okay, fine. But how can I help, bacha? Prince, you got delay, yaar. Where are you from? Are you from Bangalore? Are you from Bangalore? Okay. Actually, I'm from Haryana. Okay, fine. Prince Beta usually, I can say beta for 12th class or 11th, whatever. I have to beta be live in the night only, bacha. In the night, beta, I can say in between 10 to 2. This is live time, bacha, but usually. Maybe topic 11th to 12th class. But you are in 12th class student, so I'll be planned tomorrow, right? Once bit I can comment anywhere. There are many student. Just bit I can go and browse on YouTube. Point B.K Sir. You can put your concern in any videos. Any videos, beta. What you wanted from my side help in physics. I'll make a plan according to your expectation. Right, Bitsa? So, I'll be live it for I can see maximum time in the night only. Sir, actually, I face so many problems in solving numerical. Numerical, I'll do. I'll help. Bitsa. Is the answer 98 into 10 to the power 5? Okay, Aryan Misa. Oh, very good. I'm proud on beta, Aryan. Yes, beta, Prince, I'll guide you, Bitsa. I'll guide you, Bitsa, buddy, in numerical. I'll arrange tomorrow. Tomorrow, maybe holiday. Tomorrow is 26. So, tomorrow I'll be on leave. I'll also call Aryan and also call you. Aryan Bacha, do you want practice of electrostatics with good numerical? Then I'll be plan class tomorrow. Happy Republic Day. You say, Bacha, Aryan Beta, Happy Republic Day. Wish you all the best. Yes, beta. Prince, I'll be tomorrow alive. I'll do electrostatics. First, I'll just finish beta this numerical solution because Aryan already answered me these questions. So Aryan beta already answered me this question here. So first, I'll do bacha party. What is pressure at B bacha? Because you know, for solution Aryan bacha party, electron will be fine. Yes, electrostatics I'll do bacha tomorrow. Full numerical only bacha. Tomorrow Aryan bacha full numerical only bacha. Full numerical only. No, beta. Here, no, now. Please just imagine, yaar, 2 o'clock. Who is taking class? Just tell me example. Because, yaar, I'm in Bangalore, right? But I'm looking help for each and every candidate. Once he will selected, then yaar, anyone will get a good rank, a good, I can say, good college, good score. Then you can remind me, na, कि someone taught me in the night class like 2 o'clock, 3 o'clock, 4 o'clock. If you will ready, yaar, then I'll be ready. Don't worry, bacha. So I'll be tomorrow come for to teach beta electrostatics, right? Timing bacha, I'll beta discuss first question here because Aryan already solved this question, bacha. So Aryan beta, what I can say, this is beta open to atmosphere. Beta Aryan beta, this is open to atmosphere, beta. You can take beta P0. You can take Aryan bacha. This is what P0 bacha party. So what is pressure at B here? So what we can say, P naught plus beta, pressure increases. Pressure beta increases. So you can write beta pressure at point B. P naught plus what beta? Rho omega square x square by 2. Electrostatic, I have a problem in. Yes. Correct. Yesterday, one question came, Aryan beta. Aryan beta, I'll solve this question beta. Then I'll respond you, bacha. I'll tell you, bacha, which you wanted, bacha. P naught beta, what? 10 to the power 5. You can take, bacha, party. P naught beta, what you have taken, Aryan bacha? What you have taken, bacha? P naught? Okay, rho beta, I can take 10 to the power 3, bacha. And omega square beta, this is what? 196. X square beta, this is what? You can say 100. Upon beta g 2 here. So you can say beta 10 to the power 5, bacha, finished. You can take common iron, bacha, 10 to the power 5. 1 plus 196 by 2. Just beta, take beta finally. 10 to the power 5, bacha, this is 198 by 2. This is what? You can see, bacha, 2 9s are 18. And this is what? 99 here. So Aryan beta, I'm getting 99 into 10 to the power 5 Newton per meter square. Pressure at point B. Sir, answer will be P naught. My same answer only. What you wrote previously, Aryan bacha? No, you wrote previously wrong. Previously you wrote wrong, now you wrote right. Previously beta you wrote 98 into 10 to the power 5. But now it's fine, bacha. That is the point. You did these two questions silly mistake. I can see in the classroom there is one boy. Okay, fine. So now I look beta, I can see yesterday question, bacha. Right? Yesterday one questions came, bacha. I can see like it's not yesterday, 23rd you can see, bacha. 24 second shift. 22nd shift, Aryan bacha, there is one question asked by JEE. Literally, no, that question literally class questions only. So, my expertise, maximum student beta, I can say 23rd. 23rd beta, like you in live session, some student was asking, sir, what is the things which I have to do? Sir, I can say in 24th, means those candidate will go to write 24th examination second shift. You can't imagine, Aryan bacha, I said, beta, in current electrostatics, student B remember G2A. Beta, unfortunately, tomorrow asked by JEE, means yesterday, not tomorrow, yesterday bacha, means 24th. 24th beta asked by JEE in second shift only. You can go beta and watch. There are many sorts. I can see beta on my channel, Aryan, Prince, Yuvraj. You can go and watch. But I know during making short, I can say shorts video, beta, no, you will not get anywhere. But at the physics point, I said in advance, beta, be remember this formula, you will get. After maybe I also got response from a student. Yes, sir, I got this answer. I got this result. Galvanometer to ammeter. Galvanometer to ampere meter. No. G2A na. G2. What is ampere meter? Ampere meter is what? We have two concepts, not Aryan. Aryan bacha, we have two concepts only. G2A means galvanometer to ammeter bacha or galvanometer to voltmeter. That's all bacha party. Aryan bacha. Okay, ammeter, correct. Ammeter, ampere meter. Okay, have a look beta Aryan. Next question here. No beta Aryan, you have very good potential. Aryan beta, you have very good potential. There is no doubt, right? What's the thing beta? You are deserving right guidance. Literally, you will do beta in next year, na? Sir, physics paper of board last year. Easy. Physics beta easier for board. In fact, mains I'm calling. Beta, advance Aryan bacha little. Beta, there is mind required, right? Beta, for advance Aryan bacha, there is little very. You are too much intelligent in calculation. beta very good grip in, I can say, like just error during the, I can say, calculation, like Aryan. You can see Aryan. These two questions he did mistake. Here also he forget to add p naught, and in previous question also just forget to just square omega, right? So just these things avoid, Aryan bacha. It's highly required. It's highly required. And do hard work with Aryan. You are literally on a right platform. Physics Point is a platform in Pan India, will help you a lot. Sir, I'm in no, but it's just only focus on. That is it true. It's it true, beta Aryan. That's how I started. Yaar. 2 o'clock, 2:16. I'm going to, because I got to know Aryan. I got to know Aryan, beta. I'm in Bangalore, right? Bacha, I got to know this is thing from maximum candidate. Sir, in the classroom, either sir, they will they are concentrating more on topper, or sir, just got to know syllabus compliance only. Sir, there is not a such, I can say, a very interesting point. Sir, how can I do? How, sir, how can I improve my physics? Due to this, beta Aryan, you can't imagine. Every day I have job timing 9 or 30 minutes. Aryan, after that, once I can say, come back my home, I have to plan which student I got to just go through messages, mail, but I have to pray for mail, right? Uh, so I'll be starting separate batches for them for advance. Okay, then maybe there is also criteria. Aryan bacha, there is also criteria. If you are, I can say, your performance is good in these two means, then they will take one more batches. Okay. But they don't care. Don't worry, you are here now. Fetch will be good only. Here, student, I'll be just carry all pattern of numerical in Pan India, all institute content I have. So I'll be take good numerical from everywhere, and here I'll do all numerical, right? Okay. Now, bacha, have a look next year. Next question, beta, do Arun bacha. Arun bacha, do the next questions here. Arun JEE, what's the next questions? Find acceleration of liquids. Do Arun this question here, practice. Practice beta. We are here in the night here for practice only. Find accelerations of liquid. Find acceleration of students liquids are in hydrostatic. Aryan beta, you are in 11th class, 12th class, or dropper beta? Okay, hydrostatic condition with respect to T beta. Hydrostatic. Okay, 12th. Very good beta. Very good. 12th you can create only result here. Dropper, and I can say not potential beta. Hydrostatic condition with respect to T. Beta, you can say with respect to T. Right beta. So now beta, I'm giving you a diagram bacha, Aryan bacha. CBSE easy. I can say my laptop got erased, Aryan bacha, right? Otherwise, na, I have entire notes of 12th class of CBSE. I'll try to arrange from somewhere. Now, bacha, what's the diagram, bacha? Diagram, bacha, I'm just giving you to solve this question, Aryan. And this is beta, I can say. Aryan, bacha, which questions I'm doing here? Maybe you did it already in your, I can say, institute. Aryan, don't tell me anything. Okay. Aryan Bacha, you also from beta. I don't call your institution name. One student also study joined. No, I can say regularly he was coming today. I don't know why he is not here. But I can say those students also from the same institute, and actually he is from Kota, right? And he was also looking advanced numerical, like you. Sir, please do advanced numerical. But unfortunately, he is not available over here. So, bacha, you can take bacha. This is beta height of the liquid beta. This is beta, I can say, separator. students, I can say, Bachaji, this is the liquid. Aryan, you didn't respond me. Don't tell me anything. Aryan Bacha, you didn't respond me, beta. As I asked, which questions I'm doing here? Already you read in your classroom program or not? You have to answer me, beta. Okay, beta. This is L by 2, bacha. This is L by 2, beta. This is. I'm here. Aryan, Aryan, I'm asking to you which questions I'm doing here. You already did in your classroom or not? It means classroom program, I'm telling you. Yes, sir. Similar illustration. Very good, beta. I can say, beta, these all are standard numerical, beta. Aryan, bacha. This is L by 2, beta. This is L by 2, right, beta ji? Okay. Now, bacha, this is also L by 2, beta. This is L by 2, L by 2, bacha. Bacha, I can say, beta ji, this is the beta H is, you can do beta H is the height of liquid. H is beta, I can say height of the liquid, right, beta? Now, students, you can take H is beta, I can say height of the liquid, beta, in both of the limbs, which is equal, beta, which is equal, beta, party, right? What's the thing, beta? You can say beta from here to here till here. This is what, beta, density, you can say rho. Now, beta, you can say this is what, my dear? This is basically sigma. You need to find, beta, I can say find acceleration of a liquids are in hydrostatics condition with respect to tube. With respect to tube, beta. Or you can also tell, beta, this is a liquid A, liquid B. Yes, beta. Tell me answer, beta. Aryan, will you do, beta, or I have to do? Okay. Do, bacha. I wanted to just terminate the class now, Aryan, bacha, right? I'll connect tomorrow. Beta. First, I'll get confirmations. Then, beta, Aryan, just once you have to just write your concern, beta. Any of the videos in comment box. What's the timing for today live, beta? I'll back to you, bacha, right? I'll back to you, bacha. And we'll start 12th class electrostatics only. Just once, right, beta, Aryan? Because whatever I'll take class, complete bacha party. Whatever student I'll take the class, that is the full concept. Means electrostatics I'll start beta. So I'll take entire electro 1. If electro 2, so I'll take entire electro 2. Like that beta, I'll do. Like that I'll do, bacha. Yes, Aryan beta. Are you solving, bacha, or I have to do these questions? I can say there is one. Aryan left. No, beta, Aryan. Aryan, are you there, beta? Oh, Aryan here only. Aryan here only. Okay. Anyone from all of you? Okay. Sir, can you explain the diagram once again? Yes. Yes, beta. I can explain you. Now, bacha. So, what's the thing, bacha party? Just listen, bacha. This is beta. I can say one column, right? This is one column, beta ji. This is, you can say height is h, density beta rho. I can say the rho density from here to till here, beta, till separator. Beta rho density is this is from here to till separator. This is what, beta? L by 2, right, my dear? This is remains, beta, h. Beta height, again you can take, beta. Height in the both of the limb, beta, which is liquid field, which is remains same. But in these two, beta, I can say arm, this is a different liquid, this is the different, beta, density is sigma, this is rho. Then we have to find acceleration of liquids are in hydrostatics condition with respect to tube. Okay, now student, it's easy question. Aryan bacha. Aryan, you want more explanation or I have to do bacha Aryan? Tell me. Aryan beta, should I do? Okay, fine beta. I'm doing bacha. Aryan. Aryan, no, there is one concept beta. There is one concept student for this question explanation. If we move, what is student? If we move opposite to acceleration, beta, this is acceleration here. This is acceleration with chapati. This is A. If we move, what student? I can say opposite to acceleration. Opposite to acceleration. Then beta, what you can say? Then pressure will increase. Then beta, pressure will increase. Pressure will increase beta. This is the concept of which you can apply over here. Okay, so let us suppose beta, I'm just considering, my dear, this is a point X. This is point X beta. This is the point I'm considering by. Or you can take beta. This is point A. You can take anything beta. This is point A, this is point B. So beta, this is point A. What is, student, I can write here. Pressure at point A. Beta, this is, you can say beta, 1 atmosphere beta. This is P naught plus beta ji what? You can see rho GH. Beta, this is what? You can see beta party rho GH. This is beta rho GH. Now beta, this is, I can see beta acceleration in this direction beta party. You are going in this direction beta party. If we move opposite to acceleration, then pressure will increase. This is the directions we are moving like this beta. So what you can see? This is plus beta, what you can see? Rho A L by 2. Beta, you can see equations number 1. Sir, my phone switched off. Okay, fine. Because of you, student, I'm staying more. I'll after this, I can see numerical. Aryan, bit I'll stop live class, beta. Because of you, I'm doing more numerical, bacha. Otherwise, this is not my plan to do these all question, bacha party. Pressure at A, beta. This is what you can see, beta. Pressure at B, right, bacha party. So, bacha, I can say pressure at B, bacha. This is what beta. We are moving away and going towards. So this is beta negative. This is beta P naught plus beta sigma GH minus beta, what you can say? Sigma A L by 2. Simple beta. I hope you remember pressure difference in direction of horizontal rho A L. Just beta equate these two beta. Student, equate beta these two. Then you can say what? Sir, P naught finished. You can write what? This is rho GH plus rho AL by 2 is equals to beta sigma GH minus beta AL by, means you can say sigma AL by 2. Simple bacha buddy. Then here what you can say, we wish to find beta acceleration na. So beta just will come this side here, just separate bacha buddy. Okay, so beta, what you can see, this is GH, you can take common bacha. This is rho minus sigma is equals to beta, what you can see, will come this side here. So minus A by 2 L minus beta, you can just take common here from here. Then bacha, it's also minus here. Then you can write what? This is rho plus sigma beta. Again, you can take one minus common from here, bacha party. Then beta, what you can write? Sigma minus rho. So this is beta, you can say GH sigma minus rho is equals to beta. This is, you can say A by 2 L into beta sigma plus rho. Sigma plus rho. Just beta, you can say we wish to find acceleration here. So what you can write beta? Final answer beta. Arin vacha. Arin my dear. A is equals to beta. This is twice of GH beta G sigma minus rho upon beta Aryan. This is beta G, you can say this is L times of what beta? Sigma plus rho, right? So this is answers which you can supposed to write for these questions, right? So, Aryan beta, this is all about today class, right? Uh, Beta, I'll see tomorrow. Tomorrow, Aryan beta, class timing I have to take in the night. Beta, is it fine? Aryan beta, is it fine in the night only? Sir, can you please tell me now if Aryan has any questions, then will you take board classes and when sir? Okay, board classes. Sorry, beta. I have to take only JEE classes, means advance. Board, just I'll guide you. I'll guide you in board what you have just go through PYQs only, exam ID, that's all. So okay, Aryan bacha, this is all about today class beta. Aryan beta, which time I have to take classes? Tomorrow, night 10 to 2 only or like 12 to 2 or 12 to 3? Just tell me. Sir, when you are free. In the night beta only, night is comfortable only, Aryan bacha. In the night only bacha. No, it's fine beta, Prince. In the night beta only comfortable Aryan bacha, right? So beta tomorrow I'll become live bacha and I'll just do practice. Beta first I'll take beta fluid dynamics, right? This is statics here, one part. So maybe I'll better see tomorrow. Tomorrow because you are in 12th class na, Aryan bacha and Prince also. So I'll do for your I can say only electrostatics. Okay, Aryan bacha, all the best everyone. Till now you are in the live class. You welcome. Stay happy, stay blessed, keep yourself calm only. But all the very best, everyone. Now I'm going to just stop live classes.